Hello everyone, welcome to my channel. In this video, we are going to create pump or motor block by using function block diagram, that is FBD, from scratch by using Siemens TIA portal. Double click the Siemens TIA portal. If you are new to the Siemens TIA portal, don't worry. We are going to create the project from zero. Once the project TIA portal open, then click here to create the new project. In the project name, we will provide new name called FBD underscore demo. We will keep the same path as default. Click to create the project. Now the project is creating and this will take little bit time. Once the project created, then the device and network page will appear. For the first time, in this area, we can either open a project view directly or we can configure a device. In this case, I will double click to configure a device to create a device first. This will appear and show all the device or add new device. Select add new device. Here we have three parts: controller, HMI and PC systems. Double click the controller part. Under the schematic S7-1200, select the CPU as per your design. For me, I am going to select CPU 1214C DC/DC. Below this model, we have three parts or article number. I am selecting the mid one. Once we selected the model number, you can find the description of the product, which includes complete specifications such as power supply, DI/DO, source, sync module, AI types, communication types, IO expansion, etc. Also, if you want, we can create directly switch to project view in the left bottom. Once the project view open, then we can see the hardware device view. Once we click the Profinet or Ethernet interface, then we can configure the Ethernet address. Add a new subnet and configure the PN or IE in network. Below in the IP address, set the IP address of the port. Once the hardware configuration done, then in the next part we have to configure the PLC tags. For that, go to PLC tags, double click the show all tags. In this area, we are going to create the PLC tags. In the name section, enter any tag name which is used later in the programming section. Also in the area, we are going to add tag table, tag types, address, comments and other options such as retain, access, write and visible. Now in our case, just we will enter some example now. For that, I am going to add some input such as input 1 with default table and data type I will keep boolean and address is %i 0.0. In command, I will write that return signal emergency stop. OK. Then in the second input, I am going to write input number 2 and for tag table, I am going to create defaulting table and it will automatically take data type boolean and address the next address %i 0.1. And if you need to add more PLC tags, you can add directly from here. But in our case, see this same default tables, you can find all the tags. So in our case, just I will delete both the tags. I will show another method how to create the tags in for large projects or for big projects. For that, add new tag table and rename this tag table such as new tag list underscore FBD. Okay. Once we created the new tag list, then we are going to add the tag list now. From here I am going to add A1 and data type is boolean and keep the percentage address same default percentage I 0.0, and I am going to give here the command return signal emergency stop. Okay. And for the second tag I am going to give K0. For this I will keep the data type and address is same, and from command I am going to add main switch on. I am going to add the third signal S0 and the data type is boolean and the address is percentage I 0.2, and from here the command I am going to add mode selector manual 0 and or auto 1, automatic 1. Now I am again we will add one more signal S1 and it will take automatically the data type and address, and just I will add here push button automatic start. The next one I will add S2. Here I will add push button automatic stop. So I will copy the previous one and I will change here stop. Then I am going to add B1. For this I am going to give sensor cylinder M4 retract. And I will add the output called Q1, and in the address I am going to change, instead of input I will add output Q 0.0. For this I am going to give the command called conveyor motor M1 forward fixed speed. So just I will save these all the tags. Now I created for some tags here directly which we can use in the function block diagram. So once we saved, just I'm going to close this tag list and I'm going to open the program block. Just double click the program block and you have here add new block. Just I will close this all the menus. Double click the add new block. It will take little bit time to open the new block window. Once it's open, you can find the new blocks such as organization block, function and add block. In our case, we are going to add FB, that is function block, and the name I am going to change the name called motor underscore auto, and I will keep the function block and I will give OK now for automatic. And if you see in the program blocks downside in the main, it will automatically create a new function block. This will take little bit time. See, now it's created motor underscore auto FB1, that is function block 1. You can see here the block title and network 1, and the network 1 you have command section and execution section. So if you click here in the upside, see you can find here, then you can add here the temporary inputs, outputs, input, output, static, temporary and constant datas. In this input, I am going to add some of the input for the motor, that is called automatic underscore mode active, and I will keep the data type as boolean. And if you see default, it is false, and retain is non-retain values, and it is accessible, writable, visible in, and I am giving the command called automatic mode activated. The second one I am going to give start. For this also I will keep the default values, and I am going to add the command called push button automatic start. Similarly, I am going to copy this one, and I will give here stop, the next signal called stop. For this, just I will copy the push button automatic start. Instead of start, I am going to give stop. And I am going to add one more signal called enable OK. And if they enable OK, I am going to add the command called or enable condition OK. And also I am going to add one more signal called safety underscore shut off underscore active. So this one I will add the command called safety shut off active, shut off activated or active. So this is all input. Now I am going to add the output called conveyor underscore motor underscore automatic mode, and we can keep all the data type default value as same, and the command section I am going to add control of the conveyor motor in automatic mode, and the input output I am giving an empty, and for static I am giving memory underscore automatic underscore start or stop. I am going to enter the command as well, memory used for automatic start and stop pump for motor or pumps. If you know earlier how to use the function block diagram, you can make very easily. Otherwise you can see the previous videos which we already made for function block diagram. Okay, function block diagram, you can use one motor. The same motor, it can be repeated in many of the programs. Like example, if you create one pump, this same pump block you can use in many places. This is the use of function block diagram. Okay, if you see here, you have here AND function, OR function, empty block, and also insert inputs, invert, open branch, and also assignment. Okay, this is basic function block instructions. If you need more, you can see here you have general bit logic operations, timers operations, counter operation, compare, etc. If you click the bit operation, you can find AND, OR, exclusive, assignment, and also if you click, you can see more detail on that. Okay, this is the function of function block diagram. This is the functions you can use directly in your application. Okay, in our case, I'm going to use the assignment. Just drag and drop in the section of network 1. So you can find here directly. See, just I already just dragged and dropped here the assignment shift 1. And for this, see, for this conveyor motor, I will just drag directly the output and I will keep directly in the, see, just drag and drop to the block itself. It will automatically add the functions. Okay, this is very easy job compared to the ladder logic diagram. The function block diagram is very easy to use. Just drag and drop the function block, the name data types, and it can be added directly to the block. See, if I go for the AND block, see here, just if you click and take directly to the AND block, see, it added directly. But in my case, I am going to add before that. So what I will do now, see, if I click directly, I cannot add. See, if I put somewhere, I cannot make drag and connect directly. In this case, you have one option. I will show now. See, I am just adding now. See, it will not add directly. In this case, see, if you take this block, whenever it's come green color, this means you can join between these two blocks. This is very easy. Just take the block and join directly to the another block. See, here you have the insert input. See, you can add how many AND inputs you can add directly. If you don't need, just go and delete directly. See, I just added the enable OK, and see, now I'm going to add one more signal called set reset. See, just take this one, and if you, whenever you are giving, see, if you come near to that, whenever the green square, you can insert directly. So it is very easy to insert directly. See, now I just added the set reset, and for this it is showing question mark. No? So for that, how I can add, see, if you click and you can add directly from the place itself. See, I added memory automatic starter stop, and for set, just I will drag the start and I will keep in the set directly. See, very easy to add the tags. And for reset, I need to add one more function for this block. So what I will do now, from the right side, you have OR logic. Take the OR logic from here, just drag the OR logic and you directly insert to the R1. See here, directly insert to the R1. Just drag and drop here. So it's inserted directly. So now I'm just adding the OR logic here. See, if you need to add more, you can add from the plus button, and just browse here. You can find the signal directly. If this the signal is stop, or if the shut off valve is active, and if the signal is automatic mode active. If any of the signal is there, the pump will stop automatically. That is reset. For the start, you can give directly the set for start command. So once any of the signal is interlock is on, it will reset automatically. If the start button is on, then it will run the pump directly. So this is the condition of this motor conveyor operation. So this is very simple. This is for just for one sample how we are adding the function block diagram. And if you go to the properties, see here you can find, even if you need to change this one to ladder logic, just click here language. See the function block, it will automatically change to ladder logic. This is the beauty of beauty in Siemens TIA portal, because you can change either function block diagram or a ladder logic directly from the property itself. And one more option, if you right click the motor logic FV1, and you can change from there also. There is one more option in the properties, or from the function itself you can right click and change the you can change the block. See here, just open, see here, right click and go there. You have option for switching the function block or ladder logic diagram. And you need to know that what is OB1 or main OB1, because you cannot run the function block or any other ladder logic without OB1. You need to, because the OB1 is the main active function. I already explained in many videos. So you have to understand the OB1 is very important. If any of the logics you are creating, it should be linked with OB1. Otherwise the logic will not execute, because this is the main program in the cycle. See, now I open the OB1. If you see inside, there is temporary, TEM and constant. From here, just I am going to see here in the main function, I just add some function here. And see here also you have the same functions like block title and also network one. If you drag and drop directly to the command or anywhere, it will not work directly, because you have to first create the network one, and you have to see here you have only command only. So even if you drag, it will not work directly. See, now I just added here in the block. See, in the block you can drag. Once you created, see, it will ask you call options for motor DB1. See, it will add directly. So once it's added, it will add another network as well automatically. See, in our case, just I will show you again. This OB1 is the main program sweep cycle. Without OB1, you cannot execute the other logics, because it should be interlinked with OB1. So in any Siemens program, this is the same concept or standard. You have to use OB1. From there you can add your signal or logic. See, in our case, just I am going to add, see here also in OB1, if you need, you can insert your SEL network or the new network from right click or control, or you can insert the new networks directly. And you have these functions same like other networks. So this complete motor auto you have to use in the main OB1. For that, just double click the OB1, add the motor OB1 directly to the, and it will ask you to make a call option and enter this. It will open directly, it will create directly here itself. So now in this place you can add one by one points which one you need for motor. Example, for motor automatic you already created before, you remember. For new tag list FBD you already created the tags, so that tags you can use directly here itself. See, some of the functions, if you need negative you can add directly, or if you need to use some of the functions like AND functions, you can use directly, drag and drop here. See, now I added for enable OK, I added the AND functions, and I will add some direct link from the new tag list. See, I will add K0 %0.1, and I will add one more function called B1 for enable OK. And for automatic mode I will add the mode selector S0, and for start function I will add directly from S1, and for stop I will add S2, and for safety shut off active I already have the signal called S3. Sorry, I have already the signal called A1, and for conveyor output I already have the output called like signal called Q1. So I will add these signals. See, once you added all the signals for the pump, this means the pump is ready to connect with physical inputs, because the inputs which we configured is all physical inputs. Percentage I, 0.1, 0.2, everything, 0.3, this everything is physical input, and percentage Q 0.0 is physical output. And some of the signals stop and shut off active, I will use normally close contact directly. And just I added now one pump completely. Now we completed the complete motor application for function block. This can be used, this motor auto DB you can use in many, not only for one motor, you can use this one for hundreds of motors. And also you can export this application and this block, and you can use it in many times. So this is the standard block how you are going to create from your side with any of the applications. So once it's ready, and also you can switch over this one to function block or ladder logic as well. See, this is the overview that how to create the function block diagram, and it can be used in many places. Okay, once it's ready, just try to download this application. Now I am going to connect this function block or this application in through simulators. For that, just open the simulator, PLC simulator, download to the device. See, try to extend, but it is showing that the selector has no network connections. This means first you have to select the device. See, for that just go to the hardware device configuration and check the communication part. Double click the Ethernet network application. Already the Ethernet network is configured, and the IP address also it's configured already, 192.168.0.1. See, the subnet also it's already interfaced with the device. So this means there is no issue with the communications, but still I am facing the problem to communicate. I did not able to communicate to the PLC simulator. So what is the error? Just I need to identify first before downloading to the controller. So I need to check where is the problem. See, it looks everything is okay. What I will do now, again I will try to find the diagnostic of this. For that, just click here and try to connect again. You will find some error. Or just start simulator. See, it is showing that the simulation cannot be started because you can simulate the CPU with higher version, or higher, the firmware version is lower in our CPU. So I need to update the firmware here. Just I need to in the CPU, if you see the CPU firmware, just select the CPU. You can find the project informations. If you go further down, you can find the catalog information. Here you can find the option called change firmware version. If you click that firmware version, the current version is, for the current device is 3.0, but our new device is 2.2. Therefore this is the problem, we did not able to download to the simulator. So I just change the application to 4.4, the controller to 4.4. See, now the following editors are closed and automatically reopen, and it will affect the new firmware to the module. See, once you update the firmware, it will be automatically, see the CPU will be updated internally. So now it is ready to download to the simulator. Once it's ready, see now it's already updated. If you need, you can go again to verify the CPU version. See, it's already updated, firmware version 4.4. Now I am going to start simulation. See, now it is ready to make a simulation. So I just again I will give OK for the warning. See, it's already started the simulator. So if you have any issue with the simulator, check my previous video. You can understand more about the simulation, diagnostics and everything. And here if you see further how to download to the CPUs, I already explained in many other videos. You can understand more about the, especially for simulators, advanced simulators, and also for PLC communications and other things. If you have any clarification required, if you have any clarification, kindly notify me in the comment section. I can support you. And also if you go now for the extended download to device, I can select the PLC communication simulator and connection to the PN and I, that is Profinet or internet Ethernet communication. Now I am searching the device. It should be searched now. See here it is showing that is compiling and it's searched already, and you can find the CPU. It is selected already. Just click OK and it will ask you to download the configuration to the simulator. See, it is preparing to download to device and it is compiling the complete configuration. Once it's compiled, then you need to be load the application. Now it is checking before download, and you need to be just give the load. See here it is asking to give start module, and from no action you have to give start module and click finished. Once you click finish, then it is downloading the application to the simulator. See, now it is started for run mode. This means now it is ready to make a simulation. See, now I am going to the main application, and also double click the main, and meantime in the left side of the menu, see, you can see everything is turning to the green. This means the simulator is connected and it is activated. And from the right side you can find the monitor on. Once you click the monitor on, you can see the color of the block. It's become green, and this block it's become blue because it's not activated. This signal is not activated, both are false, so it's become blue. But the motor auto, it is in green because some of the signal is on. See here I cannot able to modify because all the signals are physical inputs. For that you have to use advanced simulator. I already explained and I already made some videos in advanced simulator. Please follow that video so you can understand how to simulate the physical inputs in any of the blocks. So watch that video, you can understand more about the signal for the physical signals. In this video you understand that how to make the new program from scratch, and also we created the function block diagram for the pumps, and how to use the simulator, PLC simulator. So if you have any clarification, kindly put in the comment sections. If you like this video, kindly press the like button and share to your friends. Thank you for watching this video. Thank you.